This is the 8th program in VTU AIML lab syllabus, K nearest neighbors. Write a program to implement K nearest neighbor algorithm to classify the iris dataset. Print both correct and wrong predictions. Java or Python ML library classes can be used for this problem. As per the question, we will have to use iris dataset. Iris is a flowering plant. These characteristics of an iris flower, petal length, petal width, sepal length, sepal width, are used in the iris dataset. This is the petal, petal length, petal width. This is a sepal, sepal length, sepal width. These four features of the flower form the columns of the dataset. Let us look at the three types of iris flowers: setosa, versicolor, virginica. Based on the values of the features like petal, sepal length and width, each row in the dataset is classified according to its type. The rightmost column indicates the type of flower. The target number values can be mapped to a list of target names. Here, 1 is setosa, 2 is versicolor, 3 is virginica. The iris dataset is provided by scikit-learn. Let us start writing the program now. We store the result of the function loadIris into the variable iris. LoadIris function is imported from the library sklearn.datasets. We need to divide the iris dataset for further processes. The features column can be called X. The target column can be called Y. More than a majority of the rows can be used for training the model. Some of the rows can be used for testing the model. Thus, we come up with four parts of dataset: X train, Y train, X test, Y test. Let us now continue the program. We had loaded the data set into the variable iris. We create four variables indicating the parts of the data set: X train, X test, Y train, Y test. Train test split is a function that can be used to divide this data set through a single line code. We need to pass the data part of iris and the target part of iris to the train test split function. Random state equals to 0 makes the same type of split every time we run the program. You may also replace 0 with your favorite number. This train test split function is provided by sklearn.model_selection library. Next, let us create the KNN model. We create a variable called KNN and initialize a method called Neighbours classifier, KNeighbours classifier. This method is provided by sklearn.neighbours library. We must import this classifier method from this library before using it. A parameter named nNeighbours equals 10 is passed to the KNeighbours classifier method. It indicates that 10 nearest neighbors are to be used for classification. Now we need to fit the initialized KNN model to the iris dataset. Hence, we pass the training data and target values, which are respectively called xtrain and ytrain. Our KNN model is now ready. Time to begin the testing of KNN model. We have with us xtest, which is the testing data part of the database. Let us traverse through the elements of xtest list through the enumerate function. Using a for loop, which provides the index I of the list and element item at the index I. Inside the for loop, we use the KNN model which we created earlier and call one of its method named predict. This method returns a target number value which indicates the type of iris flower that the current item belongs to. Pass the item to the predict method as a parameter. Since the predict method accepts only a 2D array, we wrap the item parameter with square brackets. Store the return value from the predict method into a variable called prediction. The question asks us to display all the predictions. We print the actual and prediction values on different lines. Refer to the iris dataset's target names list for both actual and prediction values. Pass the value at ith index in y test list, which contains the actual testing target values. Pass the value of prediction to the prediction print line. Use the score method of KNN model to return a number which indicates the correctness of the KNN model's prediction. The score is calculated based on the testing data and testing target values, hence pass them as parameters. That's the end of lab program. Let us now revise. First, we import the dataset. Then we use train test split to split the dataset into 4 parts. We initialize the KNN model and fit it to our training data and target lists. Next, we traverse through the target values. Next, we traverse through the testing data list and predict the target values and print both the actual and prediction values. Finally, we predict the score of our KNN model.